Conservation of energy. This video looks at the concept of conservation of energy and what it means to have open systems and closed, isolated systems. So first of all, let's look at a key definition and the law of conservation of energy. A system is an object or a group of objects being studied. So that could be a mass on a spring, a car driving down the road, or a battery and a bulb connected in a circuit. These are all systems. The law of conservation of energy states that energy cannot be created or destroyed, it can only be transferred from one energy store into another. Now, when we combine these two, we discover that our calculations that we do in physics are detached from the real world, because we always consider these calculations, where we can, as closed, isolated systems. However, in reality, the universe is full of open systems, where energy can't be created or destroyed, but it can be lost or dissipated. So let's have a look at the conservation of energy. This simply means that you cannot get more energy out of a system than you put in the first place. So if we compare that to the concept of work done, if you have a man lifting a box, the work done by the man in lifting that box will be equal to the energy that has been transferred into the gravitational potential store. Meanwhile, if we've got a car which has slowed down, as you can see in the picture, the car's tyre has begun to smoke, the work done by the brakes and the tyre against the road with friction is equal to the energy transferred from the kinetic store of the car into the thermal store of the brakes and the tyres, which is why the tyres have heated up and begun to smoke. So, open system and a closed, isolated system are as follows. Open systems are where mass and energy can move freely in and out of that system. This means energy can be lost to that system. So you could have, for instance, a pendulum. As it swings back and forwards in an open system, gradually, due to friction with the air, or air resistance, the energy will be lost to that system. Meanwhile, in a closed, isolated system, the mass and energy cannot enter or leave that system, which means that the total energy in the system will always be the same. So the pendulum would carry on swinging forever. So with our pendulum in the box, it begins to swing back and forwards. This is an open system, and so what happens is the pendulum will slow down over time due to friction with the air, and the thermal store of the pendulum will increase. However, this thermal store itself will heat the air around it. The air will gradually drift away due to wind or various other physical phenomena, and so therefore the energy will be lost to that system. Whereas with our closed, isolated system, with the pendulum inside the box, the pendulum will not lose any of its energy. Energy will be transferred from the gravitational potential store into the kinetic store and back again without any loss.